Okay, hello and welcome to this video that I'm going to be doing on the chain rule, product rule and quotient rule. This will be for A-level maths, although I'm sure that if you want to know the rules, then you can watch this video. Although I'm not going to show you how to derive the rules, I'm just going to show you what the rule is and an example of how to use it. I think that's the best way to learn, and then hopefully over time you'll be able to practice on other questions and you'll just learn which rule you'll probably want to use dependent on the question. Okay, so I'll start off with the chain rule, which is dy by dx is equal to dy by du multiplied by du by dx. And you could, if you want, imagine these du's cancelling to give dy by dx. So I'm just going to go straight in with an example on it, and hopefully, you'll be able to follow along and see what I'm doing. So here's my function y equals 1 over the square root of x squared plus 1. I could rewrite this as x squared plus 1 to the power of minus a half, okay? So you're going to need to know a bit of indices to do this as well, but hopefully you can see what I'm doing here. Now, obviously I can't do the derivative of this, I can't expand it. So what I'm going to say is, let u equal to x squared plus 1, okay? Now, once I've done this, I can rewrite the original function as u to the minus a half. And then obviously I've got the u equals x squared plus 1. Now I know how to do the derivative of this. It's dy by du, and I just times by the power, take 1 off the power, so minus a half u to the minus 3 over 2. And I know how to do the derivative of u with respect to x, which is equal to 2x. Now if I go back to my formula, you'll see that now I have dy by du and du by dx. So all I'm going to do here is multiply these two things together to give me dy by dx. So, and I'm also going to substitute in u. You don't have to do this straight away, but obviously it's important to substitute u back in, because otherwise you'll be left with dy by dx, but with the u term in there, which isn't really what you want, because you want it all in terms of x. So I suppose I could write it out like this. So it's 1 over 2, and I set u to be equal to x squared plus 1, so 3 over 2 times by 2x, okay? I'll give you a minute, hopefully you can see what I've done here, is I've literally just written this out again, but with the u substituted back in, and as it's minus a half, u to the minus 3 over 2, which is the same as 1 over to the 3 over 2, and multiplied it by 2x. Okay, and now I'm literally just going to sort of work with this and rearrange it. So I get minus 2x on top. So on the bottom, you'll notice in a second that these will cancel. And I could rewrite this here. Something to the power of a half is the square root. Okay, and something, obviously, the 3 on top is cubed, okay? And then I'm just going to write it out again, but cancelling out these 2's here, and that will give me x over the square root of x squared plus 1 all cubed, and that would be your answer for dy by dx, okay? Hopefully that makes sense. I'm now going to move on to the next one, which is the product rule. So you use the product rule if you have two things multiplied together, and the product rule is dy by dx is equal to u multiplied by the derivative of v with respect to x plus v multiplied by du by dx, okay? Again, I'm going to do an example and use this rule, and hopefully you'll be able to see. So here we go. I've got y equals e to the 2x 1 plus x. Now, even if I were to expand this, if you don't know how to do the derivative of e to the x, I'll show you how to do that in the question as well, so it should be okay. I can expand it, and I could say I can do the derivative of that easily, but I can't necessarily do the derivative of this because I'll need to use the product rule for that. So what I'm going to do is I'm going to let u equal e to the 2x and v equal 1 plus x. Now I suppose I'll split it into parts. You know how to do the derivative of v. I'm just going to denote, actually no, I'll write it as dv by dx. That's just going to be equal to 1. Now, to do the derivative of this, I'm going to go back and use the chain rule. Okay, so I'm going to say y equals e to the u, and I'm going to let u equal 2x, okay? Now, I'm going to do the derivative of y with respect to u. Now, if you do the derivative of e to the x, or in this case e to the u, it's just e to the x, or again e to the u. And I know how to do the derivative of u, it's just 2. Now, I'm going to substitute them back in to get, to get the u by dx, which is going to equal 2, because I'm timesing these two together, e to the 2x, okay? And that's a rule, basically. I suppose rather than doing this every time, if you have, say, e to the 3x, it would just be 3e to the 3x, okay? But if you feel more comfortable, there's nothing wrong with working it out like that every time. So now I'll just check my rule again. So it's u multiplied by dv by dx. So if I just go down, I can say dy by dx is going to equal u. So where's my u? There it is. It's e to the 2x multiplied by dv by dx, which is 1. And I'm going to add on to that v multiplied by du by dx, okay? I don't know why I did a bracket there, sorry. Plus v, which is 1 plus x. Okay, and like I said, I'm going to multiply that by du by dx, which I worked out to be 2e to the 2x. So to me, I was getting a bit confused there. Okay, so again, I suppose you could leave your answer like that. I'm going to work through it a little bit more just to, you know, get a nice answer. I'm going to take out a factor of e to the 2x, which is 1, 2 times 1 plus x. Okay, and this can be worked out, be expanded, sorry, in the bracket, and you'll work it out to be 2x plus 3. And you could leave your answer dy by dx as that, okay? Hopefully you can see what's going on there. So now we're on the final one, which is the quotient rule. Now this is if you have, I suppose, a fraction in terms of, so y, your function y equals u over v. The derivative of this, dy by dx, is v multiplied by this derivative, subtract u multiplied by that derivative, all over v squared. So again, I'm just going to go straight in with an example. So y equals x squared plus 3 all over 2x plus 2. Okay. Now this should be alright to see. I suppose that u I'm going to say is x squared plus 3, and v I'm going to say is 2x plus 2. Okay. Now I'm going to do the derivative of u, which I hope you can do, which is 2x, and the derivative of v, which is just 2. Okay, from here I'm just going to use the rule, so I'll show you the rule one more time. V multiplied by du by dx, so v multiplied by du by dx, so 2x, and then I'm going to subtract u multiplied by dv by dx, and then that's all going to be over v squared. So it's quite a long one, I suppose, this one, but and I'll also write dy by dx here. Okay, and now I'm just going to work through and simplify it. Oh man, this might take a while, but so I'll get 4x squared plus 4x minus 2x squared minus 6 all over 2x plus 2 all squared. Man, this is going to show how bad I am at doing this. Plus 4x 6. So that's our quadratic. Some people might be okay with you leaving it in this form, but I suppose if you wanted to, 2 and 6. I suppose if you wanted to, you could factorize it out and get it a bit neater, I suppose, in a more factorized answer. So I'm going to get, oops, sorry, you don't. Yeah, if you're happy with factorization, I'm not going to work through it fully. But you should get 2x plus 6 x minus 1 all over 2x, oh my gosh, plus 2 squared, okay? And this is your answer for the derivative, okay? Sorry if I went through that quite quickly, but literally all I did was factorize this term on the top to get that as your derivative, okay? So hopefully that makes sense, and you could follow that maybe, and get maybe a bit of a introductory example of the 3 rules and how to use them. So yeah, thank you very much.